deeper than Mount Everest is tall, colder than space, darker than night. The Mariana Trench, Earth's final frontier. A place where pressure can crush steel, where light never reaches, and where life, if it exists, rewrites everything we know.
Welcome to a deep dive into a place that honestly sounds more like science fiction than reality. Today, we're plunging into the Mariana Trench, one of the most extreme, most mysterious spots on our own planet. We've got a really fascinating stack of material you've shared with us, covering everything from the early exploration attempts to the cutting-edge science happening down there now, the incredible challenges, and even some truly bizarre life forms.
It really is an environment that pushes the absolute limits of what we thought possible for both life and technology.
Yeah.
Our mission today, looking through these sources, is to not just give you facts about the trench, but to really try and convey what makes it so utterly compelling and what secrets it might still be holding on to. Let's journey together into the deep.
Okay, let's start at the surface, so to speak. When we talk about the Mariana Trench, what exactly are we talking about? We'll think of it as the deepest scar on Earth's surface. It's the lowest point in any ocean, a massive crescent-shaped depression in the seabed. It's in the Western Pacific Ocean, just east of the Mariana Islands and near Guam, part of a whole global network of these deep trenches.
And the scale is it's mind-boggling. The sources say it stretches about 1,580 miles long. That's huge.
It is incredibly long.
But surprisingly narrow, right? Only about 43 miles wide on average. And then there's the depth. Its lowest point, the Challenger Deep, goes down to around 11,000 meters?
Yeah, about 6.7 miles straight down. To give you a sense of that, one source points out you could drop Mount Everest into the Challenger Deep summit first.
And it would still be underwater.
And its peak would still be more than a mile underwater.
Yeah.
Another comparison was like stacking 34 Eiffel Towers.
Wow.
And I like this one. It's deeper than the cruising altitude of a commercial airplane if you flip the airplane upside down.
Okay, that comparison really hits home. And what does that kind of depth create down there? What's the environment actually like? Yeah.
Well, it's almost alien. Completely isolated from the surface world. Sunlight, it disappears within the first few hundred meters of the ocean.
Right.
So down there, it's in constant, absolute darkness, total blackness. But the most dominant force, that's the pressure.
Right, the crushing pressure. We hear about that all the time.
Exactly. We're talking about over 1,000 times the atmospheric pressure at sea level.
1,000 times.
That's more than 16,000 pounds per square inch.
Yeah.
One source used this really vivid image, like being squeezed by the weight of 50 jumbo jets all at once.
50 jumbo jets. That's unimaginable.
It is. The pressure is so intense, it literally compacts the air out of things. They talk about experiments like sending down a styrofoam cup or even a wig head, and it comes back up, shrunken to a fraction of its size, all the air just squeezed right out. A human body, of course, well, it would be instantly pulverized. It's an environment that exists completely outside our everyday experience.
It sounds utterly hostile. And geologically, how did this incredible feature even form? What makes it so deep?
It's a result of plate tectonics, basically. The slow, relentless movement of Earth's crustal plates. At the Mariana Trench, the huge Pacific plate is actually diving or subducting underneath the smaller Mariana plate.
So one plate sliding under another.
Exactly. And that bending process creates the deep trench on the seafloor. It also fuels the chain of volcanoes that form the nearby Mariana Islands. It's Earth's surface literally being consumed right there.
Wow. So how did we as humans even figure out this place existed? When did we first realize how deep it was?
Well, our sources trace the first real inkling back to the age of early oceanographic exploration back in the 19th century.
That started with the HMS Challenger expedition, right?
Yeah.
In 1875.
That's the one.
They were doing these pioneering global science voyages, using sounding equipment, basically dropping weighted lines with thermometers attached. And they registered a remarkably deep point, something like 8,140 meters, which must have been astonishing for the time.
Absolutely. And then fast forward over 7 decades to 1951, another British vessel, the HMS Challenger Désiré, returned to that same area. This time they had much more advanced technology, echo sounders, and they measured an even deeper point, 10,863 meters.
Okay, much deeper.
Yeah. And so to honor the work of both of those groundbreaking ships, that deepest part of the trench was officially named the Challenger Deep.
Right, after the two Challengers. Makes sense. For decades after that, though, our knowledge was mostly based on these remote measurements, soundings.
Exactly.
But then in 1960 came the first attempt to actually see the bottom. This is where the story gets really dramatic, isn't it?
It really is. That was the mission of the bathyscaphe Trieste. It was this revolutionary submersible. Part of the design actually came from Auguste Piccard,
The balloon guy.
the very same, based on his experience with high-altitude balloon gondolas, believe it or not. His son, Jacques Piccard, partnered with U.S. Navy Lieutenant Don Walsh, and together they made the first ever crewed descent to the deepest known point of the ocean.
And the Trieste itself sounds like something out of a Jules Verne novel. The crew cabin was just this tiny sphere, wasn't it? Maybe 6 feet across.
Incredibly cramped, yes, but with walls 12.7 centimeters thick, that's about 5 inches made of solid steel. Specifically designed, of course, to resist that immense pressure.
Wow.
The craft itself was quite clever. It used lighter-than-water gasoline for buoyancy.
Gasoline?
Yeah, and heavy iron pellets as ballast, which they could release electromagnetically to start ascending again.
Imagine being squeezed into that tiny metal ball like the size of a big fridge for a journey that lasted 9 hours in total.
9 hours.
It must have been incredibly cold inside, too. One source recounts this terrifying moment. About 2 hours into their descent, maybe 20,000 feet down, they heard this loud, sharp crack.
Yes, that must have been absolutely terrifying. The outer pane of their thick plexiglass viewport had cracked.
Oh my gosh.
Interestingly, the sources suggest it wasn't actually the pressure at that specific depth, but probably the extreme cold that caused it to fracture.
Still, the pressure outside must have been huge already.
Oh, immense. And they had to make this instantaneous life or death decision. Do we abort the mission right now, or do we keep going down? With only a single pane of glass holding back over 8 tons of pressure per square inch.
And they kept going.
They kept going. Incredibly, the inner pane held. They continued their descent, which took nearly 5 hours in total.
5 hours just to get down.
Yep. They spent just 20 minutes on the bottom the deepest humans had ever been, and then another 3 hours and 15 minutes coming back up. Their instruments initially read a depth over 11,500 meters, which was later slightly revised, based on pressure calculations and water density, to about 10,916 meters. Still incredibly deep.
It truly is one of the great feats of exploration, and it's striking, looking at the sources, how few people have followed them into the Challenger Deep since then. One source actually points out, fewer humans have been to the very bottom of the ocean than have walked on the moon.
That really puts it into perspective, doesn't it? The list of individuals who have descended is very, very exclusive. It includes, of course, filmmaker James Cameron, who made that famous solo dive in 2012.
Right.
And more recently, the explorer Victor Vescovo and his 5 Deeps expedition team. They set a whole bunch of new records, including the deepest ever dive by a woman that was Catherine Sullivan, the astronaut.
An astronaut going to the deepest point on Earth.
And the first father-son team to descend, Don Walsh's son, Kelly Walsh, went down.
Oh.
And the first Pacific Islander, Nicole Yamase. These modern expeditions really highlight how it still requires incredible technological resources and, frankly, a lot of courage.
Which brings us neatly to the exploration challenges. Why is it still so incredibly difficult to get down there, even with all our modern technology?
Well, it really comes down to the sheer physics of it, as we discussed. That crushing pressure, the near-freezing temperatures, the total darkness.
No.
It all requires equipment that is almost disproportionately robust and incredibly expensive to design, build, and test. I mean, think about it. It has to function perfectly under conditions that would instantly flatten a conventional submarine or even most military subs.
That's why only a small handful of highly specialized submersibles and remotely operated vehicles, ROVs, have ever successfully made it all the way to the bottom over the decades. You read about vehicles like Japan's ROV Kaiko, the U.S.'s hybrid Nereus, Cameron's Deep-Sea Challenger, of course, and Vescovo's DSV Limiting Factor. Just a few names.
Exactly. And Cameron's 2012 solo dive in the Deep-Sea Challenger was really significant. It was the first solo human dive to that depth, and he brought back just stunning footage. It visually showed us what the deep-sea floor looked like in a way we hadn't really seen before. Changed perceptions.
But it's not just difficult, it's incredibly dangerous. The sources remind us that even with advanced tech, failures can be catastrophic. They mentioned the Nereus ROV.
Yeah, the Nereus.
Which successfully explored Challenger Deep in 2009, but then tragically imploded just a few years later while exploring another deep trench, the Kermadec Trench.
That's right, a stark reminder of the risks. And there's that absolutely fascinating story from 2014 about the acoustic instruments they were using.
Oh, yeah. Tell us about that one.
So they deployed 2 free-falling probes. They were designed to measure the depth very precisely using sound pulses. But one of them, the Deep Sound MK3, which was rated for 11,000 meters,
Yeah.
well, it failed.
It imploded.
It imploded catastrophically at around 9,000 meters down. The immense pressure just caused its glass pressure housing to shatter violently.
That must have sent a massive shockwave through the water, a huge bang.
It did, a huge
Yeah.
acoustic event. And here's the incredible part. The other instrument, Deep Sound MK Clinet, which was nearby and survived, actually recorded the sound of that implosion.
No way.
Yes. It recorded the direct sound and, crucially, the echoes of that sound bouncing off the seafloor below and the ocean surface way above.
So they use the sound of the failure itself as a scientific tool.
Precisely. It's really ingenious when you think about it. The scientists were able to analyze the precise timing of those echoes from the implosion, using it like a perfectly timed, very loud sonar signal. Combining that echo timing with the sound speed data they got from the surviving instrument, they calculated one of the most accurate, highly constrained acoustic estimates for the depth of the Challenger Deep. 10,983 meters, plus or minus only 6 meters.
That's incredible precision from basically an accident.
It is. It's a stark reminder of the risks involved, absolutely,
Yeah.
but also shows the immense cleverness required to extract data in such an unforgiving place. They literally turned a catastrophic failure into a really precise scientific measurement. Even noted how reflections off the uneven seafloor added some uncertainty.
Okay, so you'd think a place that is perpetually dark, near freezing, and under that kind of crushing pressure would be utterly devoid of life.
Right.
Just
Yeah.
barren.
That would be the logical assumption.
But the sources reveal something truly unexpected. Life is down there.
It's not just surviving. In some ways, it seems to be thriving. Even those early HMS Challenger expeditions back in the 1870s found evidence single-celled organisms, radiolaria, in their dredged samples. And while there's that ongoing debate about the Trieste cruise report, Picard swore he saw flatfish on the bottom.
All right. But modern biologists are pretty skeptical about that one.
Yeah, they largely doubt it. The thinking is it was much more likely a sea cucumber, a holothurian, which can look sort of flat. But regardless, modern robotic missions, landers with cameras, they have definitively shown that life exists down there. And in surprising diversity, sometimes abundance.
Yes, the images are wild. I read about these giant single-celled organisms called xenophyophores. They look like huge amoebas, apparently over 10 centimeters across.
They're quite remarkable. Huge single cells. The most common inhabitants observed right down in the Challenger Deep itself seem to be these giant amoebas, the xenophyophores. Also small sea cucumbers, holothurians, and amphipods.
The amphipods, those little shrimp-like scavengers. I loved that anecdote I read about James Cameron's team putting down bait, like a chicken carcass.
Yeah?
And apparently the amphipods just swarmed it instantly, stripped it clean like piranhas. Someone described them looking like giant sea monkeys.
They are incredibly efficient scavengers, yeah. They seem to be everywhere down there when there's food. And what scientists have discovered about how they survive the pressure is truly fascinating.
How do they do it?
Well, their shells, typically made of calcium carbonate,
Sure.
should dissolve under that intense pressure and in that cold water. But one study found a particular species of amphipod down there. It actually extracts aluminum from the seawater and incorporates it into its shell structure. It basically builds itself aluminum armor.
Aluminum armor. Seriously. To withstand the pressure. Seems like it. Makes the shell incredibly strong and resistant to dissolving. It just highlights the extraordinary adaptations required for life at these depths. And scientists are continuously discovering new species. The Mariana snailfish, for example, was filmed at 8,000 meters. For a while, it held the record for the deepest living fish ever captured on video.
What do they look like?
They're often pale pink, kind of ghostly looking, and lack scales. They seem to be the dominant predators at those immense depths, feeding on the invertebrates like the amphipods.
And the sources mentioned something interesting, that different trenches, like the Mariana versus others, seem to have slightly different species, like variations in the snailfish found in one trench versus another.
Right, and that connects to a bigger picture understanding of the deep sea, specifically these ultra-deep parts called Haddle zones, anything below about 6,000 meters. For a long time, the view was that these deep trenches were like isolated pockets, biological islands, if you will, separated by vast, shallower abyssal plains.
So life would evolve separately in each trench. That was the idea. This isolation could lead to unique evolution speciation, which would explain why you might find a distinct snailfish species in the Mariana Trench compared to, say, the Kermadec Trench halfway across the Pacific.
Yeah.
Limited gene flow between them.
But is that view changing? Is it more connected than we thought?
It seems it might be more complex. New research, discussed in the sources, is revealing that the total Haddle area on Earth is actually much larger than just the main famous trenches. It also includes these previously overlooked deep basins and fracture zones, and there's a possibility that some trenches might actually be connected by deeper pathways, sort of Haddle corridors.
Oh, okay.
This challenges that idea of complete isolation for all trench systems. It suggests gene flow might occur between some, allowing species to spread, while other trenches might remain truly isolated. It shows the deep sea is far more complex and dynamic, perhaps less like isolated islands than we initially thought. Our understanding is definitely evolving.
Thinking about all this mystery, the unique life, the sheer extremes, it really makes you wonder, doesn't it? Why does it sometimes feel like we know more about distant planets, light years away, than we do about the bottom of our own oceans, which are right here on Earth?
It's a really valid point. And the sources confirm that feeling estimates are that only about 5%, maybe a bit more now, but still a tiny fraction, of our total ocean volume has been thoroughly explored. Space exploration often captures the public imagination, rockets, other planets. It has historically received maybe more consistent funding and certainly a lot of media attention.
Yeah, definitely.
But the deep sea, particularly these Haddle zones like the Mariana Trench, might hold answers that are just as fundamental, maybe even more so, to understanding life, geology, and how our own planet works.
Perhaps because the deep sea feels both right here, part of our world, and yet utterly alien at the same time. It taps into something primal, maybe?
Could be.
Those ancient fears and fascinations with myths, legends, sea monsters that still kind of stir our curiosity about what truly lurks beneath the surface. Maybe we instinctively fear the crushing darkness and intense pressure of the deep ocean in a way that feels more immediate, more tangible than the perceived emptiness of outer space.
It's an interesting way to put it. And while it feels so remote, so alien, the practical question arises. Who actually owns this deepest point on Earth? Does anyone?
Well, geopolitically, the sources make it pretty clear. It falls primarily under the jurisdiction of the United States.
Okay.
Because Guam is a U.S. territory and the Northern Mariana Islands are a U.S. Commonwealth, the U.S. has regulatory authority over the Mariana Trench within its exclusive economic zone, or EEZ.
Right, the EEZ. And its ecological significance was formally recognized too, wasn't it?
Yes, back in 2009, President George W. Bush established the Mariana Trench Marine National Monument. It's huge, protects over 95,000 square miles.
95,000 square miles.
Yeah, includes the trench itself, areas around 3 of the northern islands, and also a string of 21 underwater volcanoes known as the Mariana Arc of Fire.
Wow, so it covers quite a diverse range of deep-sea features.
It seems like really crucial protection for some incredibly unique habitats. Like they mention the Mogg caldera within the monument, where life apparently thrives near these intensely acidic, boiling hydrothermal vents. It's like a natural laboratory showing how life adapts to extreme chemistry. Maybe even giving us hints about how organisms could cope with increasing ocean acidification globally.
That's a key potential insight, yeah. But despite its remoteness, despite its protected status, the trench isn't entirely untouched by human activity from the surface world, is it? The sources contain some pretty alarming information about pollution down there.
You mean finding things,
Yeah.
human-made things, reaching the very bottom.
Exactly. Research has found surprisingly high concentrations of PCBs. Those industrial chemical toxins that were banned way back in the 1970s.
Yeah.
They've made their way down to the very deepest point and are accumulating in the food web, concentrating in the organisms living there.
That's deeply concerning. Banned chemicals from decades ago.
It is. And perhaps even more worrying in some ways is the discovery of microplastics. One study mentioned finding microplastic fibers and fragments in the stomachs of 100% of the amphipods they sampled from the trench. Every single one.
100%. So plastic pollution or plastic waste has definitively reached the deepest, most remote, supposedly most protected place on the planet.
It certainly seems so. And other markers of surface activity too, carbon-14, left over from atmospheric nuclear weapons testing decades ago, has also been detected in deep-sea creatures there.
Wow.
It's just a stark reminder that our actions on the surface have truly global reach, impacting even the places we think of as being the most distant, the most isolated from us. Nothing is truly separate.
So bringing it all together then, given the incredible challenges, the danger, the expense, the remoteness, Why does exploring this extreme place truly matter? What's the bigger picture?
Well, I think it goes beyond just mapping the seafloor or collecting samples, though those are important too. Exploring the Mariana Trench is fundamentally about confronting the ultimate unknown on our own planet. It pushes the absolute limits of human ingenuity and engineering just to get there and operate. And perhaps most profoundly, by studying life that survives, even thrives, under conditions we once thought completely impossible.
Hmm.
It forces us to rethink what is possible for life itself to endure, where it can exist.
So, could studying life in these dark, high-pressure environments often powered by chemistry instead of sunlight, could that give us clues about the potential for life on, say, icy moons elsewhere in the solar system? Places like Jupiter's moon Europa or Saturn's moon Enceladus, which are thought to have vast subsurface oceans under ice shells.
It's certainly an intriguing possibility, and one scientists are actively considering. The adaptations we're finding down their life using chemosynthesis, organisms withstanding incredible pressure. They provide tangible examples of how life can exist without sunlight, powered by geological processes under extreme physical constraints. It definitely expands our understanding of the potential habitable zones, both on Earth and potentially elsewhere.
And then there's that more philosophical question you touched on earlier. What does it say about us as a species that we seem to harbor maybe a deeper, more visceral fear, or perhaps just a different kind of curiosity about the deep oceans of our own planet compared to the perceived emptiness and vastness of space? Why does one feel more alien or scary than the other, perhaps?
It's fascinating, isn't it? Both frontiers capture our imagination, the deep sea and deep space. But maybe the deep sea is intertwined with our ancient human stories, our myths and mysteries, in a unique and perhaps more unsettling way because it's right here, still largely unseen. In the silence of the deep, there are no borders, no politics, no cameras, just the crushing truth that we still know so little about our own planet. The Mariana Trench is not just a place, it's a reminder that Earth still holds mysteries we've barely touched.
We hope you enjoyed this deep dive into Earth's deepest point. Stay curious, stay grounded.